Let's move on now. Small-scale integrated circuits became commercially available in the early 1960s. There's some debate amongst our panelists as to when exactly that happened. It's actually not relevant. Fairchild Micrologic was one of the first families. The early parts had very low noise immunity, and they weren't very well commercially accepted. How was their performance improved so that they were commercially accepted? Bernie, you want to take that?
Well, the way Fairchild did it, they just cut the price. And because the RTL...
They didn't improve the performance?
They did try to improve the performance, but it was minuscule improvements compared to monumental price decreases. And I think that sold most people on trying it, because you could get fairly cheap logic compared to what it started. They start out $120 a circuit, and pretty soon they were down in a much lower level.
Yeah, by 64, Bob Noyce, I think, had cut the price of an RTL gate in 100-piece quantities to $1. So it was really quite incredible. It was in a rather interesting plastic package, though, that that caused a lot of issues until people came out with better kinds of plastic.
When did the ceramic package come out?
Well, the ceramic packages were very early. The metal seals and ceramic seals. The Surdit package that we're kind of familiar with came out in 64. There just were not many plastic packages early on. They just weren't reliable. Really weren't.
Ed, do you have any comment on the packaging? Since you
I was going to say there were in the transistor area, there were basically two kinds of plastic packages. There was the one that the commercial, radio devices were sold in, which was basically called the glob top, TO-105, 106, which is basically a ceramic bead with metal leads with the device assembled and then over-poured with epoxy. And yes, that had some reliability challenges. Then later, the devices got put into a lead frame with a molded body, and that improved the integrity. Clearly, one of the complements or attributes of the planar transistor is that over time it allowed significant improvement in manufacturing of the device, the assembly and test. I went back and counted back in 1960-61 and compared the number of process steps we had at that point in time to the number of process steps we had by 75, and they were reduced by more than 50%. We'd reduced more than half of the various process steps just through the improved reliability, the ability to use different materials, the ability to go to molded devices, made a significant difference in terms of number of steps, and with that in terms of productivity and ultimately cost.
Thanks a lot, Ed, for those coaching comments.